Okay, good morning friends. Last time we discussed about that is chapter number 10, gravitation, that is importance of the universal law. So in this topic we discuss about the force that bind us to the earth, the motion of the moon around the earth, the motion of the planets around the sun, and the tides due to the moon and the sun. Also we discuss about the free falling. So here that is for that we take the one football and kick it in upward direction, that is reaches the certain height and then it start the falling. Okay, so here whenever objects falls towards the earth, okay, under the gravitational force, and we say that the objects are in free fall. And finally last time we discussed about that is we deduce the equation small g is equal to capital G capital M upon r square, where small g it is the universal, that is the gravitation, capital G is the universal constant, capital M is the mass of the earth, and r is the radius of the earth. So here in this topic, that is to calculate the value of the g. So here we should put the value of the capital G, capital M and capital R. So here the universal gravitational constant capital G value 6.67 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Capital M is the mass of the earth and its value is 6.6 multiplied by 10 raised to 24 kilogram, and the radius of the earth, that is capital R, that is 6.4 into 10 raised to 6 meter. Okay, and all this value we have to substitute in this equation, that is small g is equal to capital G capital M upon r square, and finally we obtain the answer 9.8 meter per second square. And the value of the acceleration that is due to the gravity of the earth, that is 9.8 meter per second square. Now next one, that is the motion of object under the influence of the gravitational force of the earth. So for that we take the one activity first, that is 10.3. so for that we take the one sheet of the paper and a stone. So both paper and the stone we have to be dropped there simultaneously from the certain height of the building, and observe whether both of them reaches the ground simultaneously or not. So we observe that here the paper reaches the ground little later than the stone, and this happens because of the air resistance. The air offers the resistance due to the friction of the motion of the falling object, and the resistance offered by the air, okay, to the paper is more than the resistance offered to the stone. So here that is an object experience, that is acceleration during the free fall, and the equation, that is small g is equal to capital G capital M upon r square. So this acceleration experienced by the object is independent of the small g, that is independent of the small m. It does not depends on the mass, it does not depends on the small m. Okay, it means that all objects, that is big or small, hollow or solid, should fall at the same rate. Okay, now according to that story of the Galileo, okay, drop different objects from the certain height from the top of the Leaning Tower of the Pisa in Italy, prove that the same situation. Now here, that is as g, small g is the constant near the earth, okay, its value is 9.8 meter per second square, and all the equation for the uniform accelerated motion as we have to study in chapter number 8, okay, that is v is equal to u plus at, s equal to ut plus 1 half at square, and v square minus u square equal to twice as, that is v square equal to u square plus twice as, and here u is the initial velocity, v is the final velocity, and s is the distance covered in the time t. Here acceleration is to be positive when it is in the direction of the motion, and acceleration a will be taken negative, okay, when it opposes the motion.